Hi everyone, welcome back. Looking at Technical Graphics 2012 higher level example, and we're looking specifically at auxiliary projection. Okay, now this is something that's, can come up in a higher level question. When you have a true shape to be found, you can find it by either rotation or auxiliary. And in our case here in the short questions, we're given a setup for an auxiliary. So we're going to have a little read of the question, see what needs to be done, and then get on with it. So the figure shows the elevation and plan of an axe head. Okay, and you can see the axe head here. And it says a 3D graphic of the axe head is also shown. That's the elevation, that's the plan, and this is the 3D graphic. Project an auxiliary elevation of the axe head on the line x1, y1 to show the true shape of surface S. And here's surface S here. Okay, and what we have here in the plan view, okay, and I'm going to write a few notes on this, kind of explanatory notes as we go along, is we have the edge view, surface S. Okay, now why is that edge view so significant? Well, when we try to find the true shape of any surface, we always align our auxiliary view with that surface S. And we'll note here as well that if I were to, for example, line up my set square with that line for surface S and bring it out to the x1, y1, we'll see that they're the same angle. Okay, so the edge view and the x1, y1 will always be the same angle. Okay, and in this case what we're going to do is we're going to project out from the plan view, and we're going to take the measurements from the elevation and step them out on this new xy line, because an auxiliary elevation is just another elevation, only it's at a different angle. So for example, this is an auxiliary view, if you want to call it, but it's just an auxiliary view at 90 degrees to the object. Whereas now, whatever angle this is, it's an auxiliary view of whatever angle that is. Okay, so here's our elevation, imagine, and now we're changing the position. We're looking at the object somewhere around here, and we're looking in at it, and we're getting another elevation here. And the one thing we must always remember when we're doing an auxiliary elevation, the heights for each of the points will not change. Now the view we get in the end of it will, but the heights won't. Okay, so bear that in mind, and we always take the heights from the xy line up to each point in the elevation itself. Alright, so we'll get on with it. First thing I'm going to note here, alright, and you don't have to do this in the exam, but just for explanatory purposes, I'm just going to extend a kind of a series of little lines out to the side here, and I'm just going to take note of the different measurements that we have. Okay, alright, so just put little arrows there. I'll call this H1, call that H2. Okay, and of course the ground itself, we can call that H0. Okay, H0. Now I am just going to reference the heights there, because in the event of me labeling points, and some of you might label and some of you might not, okay, that's entirely up to yourself, but it does help when you're joining up points in your new view, your new elevation. For example, if I was to label the points here, this point, we'll take surface S for example. I'll call that point 1. We'll call this point here 2. We'll call this point here 3. We'll call this point here 4. So, if I were to say to you, what heights are points 1 and 2 when we project them out in their new elevation? Well, 1 and 2 are both on the line H0, on the ground, on the XY line. So that means they'll be on the XY line here. Point 3, what height would we mark point 3 out at? Well, obviously, like, we measure it and mark it out, but if we can reference it here, point 3 will be at the height of H1, wouldn't it? So we'd mark that out. Point 4, that'll be at the height of H2. Alright? Let's slide that over a little bit more so you can see it. H2. So I'd mark that out. Okay? So what I'm going to do here now, and I'm very keen on developing kind of little shortcut techniques, is we're going to just label the points for surface S in the plan view here as well. So surface S is just this line here in plan view, because we're looking down on top of it. Okay? So here we have point 4 and 1. And why is it 4 and 1? Because 4 is on top of 1. And this here is point 3 and 2. And why is it 3 and 2? Because 3 is on top of 2. Okay? So, with that said now, what I'm going to do is, at a right angle to the X and Y1 line, we are going to project out. And it's very important that we get this right. So whatever angle your X1, Y1 line is, you project out at a right angle to it, or at 90 degrees to it. Now you could go ahead and you could measure that with a protractor, okay, and you can find the angle that way, alright, and that's one way of doing it. Or here, you can just take your X1, Y1 line, because it's given to you here, in this example, and you can take your set square, okay, and here's a little trick for you. I'm going to line up the inside line of my set square with the X1, Y1 line, like so, and it's the reason why I extended that line. And I'm going to line up the outside line of my set square with the point 32, for example. Could be any point on the object, and I'm just going to draw a line up there, like so, very lightly. That line is at 90 degrees, isn't it? Because this angle on the set square is 90 degrees, so we use the inside to line up with the XY line, and the outside we push it over then to line up with the point we want to bring on. Now, once we have one line, we can use our sliding set squares method from there on. Okay? And I'll zoom out for that in a moment. So, you can see there, I have one line brought on there. We'll take a measurement for it in a moment. But what I want to do is, on that line, I am going to take the measurements from, that'll be like H0, that line, wouldn't it? Okay. And you'll have to pardon me for doing this quite slow, because I just want you to be sure. I'm going to take H1, I'm going to mark that out there. Okay. Now that's coincidentally going to be, this will be point 2 and that will be point 3. But I want to mark out these lines first. So I'm going to take H2 here now on the compass, like so, and mark it up on the same line. So that first projection line, I'm actually using that like as a construction line as well. Okay? And what I'll do here is, parallel to the X1, Y1 line, and I'm just using my sliding set squares here. I'll bring in the other set squares so you can kind of see it there. I am going to line up there, and I'm just going to create two construction lines like that. Because what this will do is it saves me having to constantly measure all the time. Okay? And you'll see the way I'll go about it here. Next, what I'm going to do is I'm going to go back and I'm going to bring out the rest of those points. So, use my sliding set squares again, okay? And you'll see I have one set square underneath. If I zoom out for a second, you'll see what I'm going to do is line up this set square here with the line. I want to make sure that that is lined up perfectly, like so. And once I'm happy it's in line, I will put the other set square underneath it, okay, and keep this one stable so this one can move freely along. Okay, so what I'm going to do there is I'm going to use my blue pen now. I'll just go over this first line again, and I'm going to project all the points out, front and back, and I'm going to extend them all out to the second green line, regardless of where they actually are, their heights, for the moment. Okay, now next thing I want to do, this circle here, it's not going to be a circle in the auxiliary view, it's going to be the very same as it is in this elevation, only it'll be orientated in a different direction. So what we want to do there is to be right about it, we'll want to take our XY line parallel again, okay, and slide down to the center point of the circle there now, and just draw a line lightly across like that. Okay, that's going to give us the outside points, the exact outside points. We just don't want to line up at the edge of the circle and draw it out. We want to do it right. Okay, so now I'll go back here, and I will again get my blue pen, slide over, make sure we're in the right position, and there we go. Okay, now let's figure out the points. Okay, so here we go. So this line contains points 2 and 3. 2 is at height h0, so that's 2 down here. 3 is at the height h1, so that's 3 there. Lovely. We'll zoom in a little bit now. Okay, so I have 2 and 3 found. I'm not going to draw anything for the moment. I'm going to go to points 1 and 4. Okay, so point 1 is on the ground, h0, so follow the line out from 4 and 1. There we go, there's point 1. And then point 4 is up here at the height 2, so that's the height 2 line, and 4 is on the same line as 1 coming out, so we mark point 4. Now there are many different ways to do auxiliaries, but this is my preferable way. Okay, and I think once you get the hang of them, it's very repetitive. Okay, I'm going to heavy in this surface here for a start, because I do know that this surface is perfectly visible to me, and it's also the true shape surface. So I just want to kind of make a point of highlighting that first, and I'll use a little bit of colour now as well, and I think it's no harm in the exam just to take literally a few seconds to apply a bit of colour to that surface, and to write in S on that surface. Okay, so there's the true shape, okay, of surface S right there. So you could put TS on that if you wanted, just highlighting S. Now, so what I want to do is, if I continue labeling the object, let's label the other points that are on the front here. Let's say, for example, these 2 here. We'll call that, well, if that's 1, 2, 3, 4, let's say we call this point 5, and we call this one down here point 6. Okay, so 5 and 6, where are they in the plan view? Well, they're right here, aren't they? So that's going to be 5 on top of 6, isn't it? Because we're looking down on top of them there. So if we look at the heights again, 6 is on the line h0, so it's on the xy line, so that's point 6 there. And point 5, where is that? Well, point 5 is on the line h2, isn't it? So follow the line out, there's 5 right there. So what I do there now is I'm going to heavy in that section. So you can see I'm building my picture as I go along. Alright, so that'll be the, like this surface here containing 1, 4, 5 and 6. That's it right there. And if you wanted to, you know, again, highlight that with a little bit of colour, well, use a different colour there on that surface. And it doesn't have to be anything fancy. And there we go. Now that surface, it's not a true shape like this one, because we were looking directly in at the angle, the right angle to that edge view of the surface S here. So I got the true shape of that, but this here is kind of, you know, just like, it's not the true shape. But it is part of the new elevation view that we're creating here in our auxiliary. Now let's have a look at the other points. Okay, let's say we label the points here behind 5 and 6 here in the plan view. Let's say we call them 7 and 8. 7 and 8. Okay, now where are 7 and 8 in the elevation? Well, 7, because it's on top of 8, so 7 is going to be behind point 5. Okay, and 8 will be behind point 6. Yeah. Now, in our auxiliary view though, 7 and 8, that's their projection line going out. 7 is at height 2, so I can mark 7 there. And 8 then is at height 0. So it's on the XY line. So that's 8. Now, what's special about that line? It's in at the back. So it gets a broken line. Hidden detail. Okay? Like so. So that's 7 and 8. Now let's have a look at other points that we need to get. Well, there's a set of points here behind points 4 and 1. So let's go to that there. We'll call that 9 and 10. 9 and 10. Now, in the case of the elevation here, 9 will be behind 4 and 10 is going to be behind 1. Okay? So 9 is at the height of 2 and 10 is at the height of 0. Okay? As we can see there. So we'll follow the line out for 9 and 10. So lo and behold, there's point 10 on the ground, as it is here. And then point 9 is going to be above here at height 2. So now what I'm going to do there, okay, is I'm going to connect across point 4 to point 9, like so. And then what I'm going to do, 9 joins to 3. So I can join that up. And that creates that triangular part here that we see. And it's no harm to reference surfaces here now and again when you're going through it. So I'll shade in that little bit of a surface there. That triangular bit there, okay, is the bit we've just found there. And again, I'll just take a little bit of a colour there, just so we can separate that and actually see it. Now we'll also bear in mind that there's a line connecting 9 to 10 behind, and it's going to be a broken line because it's a hidden detail, and you can see it behind there. Okay, apologies that I wrote S in the way there. Now we have just one part left, and it's the detail for this circle. Okay, so we have the projection lines going out, and we know that based on the elevation here, it's going to be a hidden detail top to bottom. Okay. So that's what we have there. Now, I have taken a kind of a long way of explaining that to you, but I just wanted to give you that idea, that framework method for setting up your auxiliary view with the least amount of complication possible. I suppose the last thing we could do there is we could add in the center line for that circular bit, because if you had an engineering drawing, which is if you were a mechanical engineer and you had that circular hole there, you would be looking for a long dash short dash line, okay, going through the center of it. Alright, now, and we don't need to if you wanted to try and separate it with a little bit of colour, you could just shade something else gently in there just to highlight that there's something in there behind. But other than that, that is the completed auxiliary view. And here's the key, okay, when projecting from plan, which we did, take measurements from the elevation. And that's specifically for an auxiliary elevation. Now, if we were doing an auxiliary plan view, it would be the opposite. You would project from elevation and take the measurements from plan. That would be the opposite way around. However, this is what we had here today. Okay? And I hope you found it useful and enjoyed it. All the best. Have a good day.